Olá, Hércio, já podemos começar?
Vale.
Tá bem, estamos em vivo em YouTube. Bom, passamos ao inglês, está bem, Alicia?
Perfecto, sí, sí.
Well, good morning, everyone. Good morning for you that are watching us in the YouTube channel of the Institute of Chemistry of the São Paulo State University. Good morning for the people here in the room of the Google Meet session. Good afternoon for Alicia in Spain. It is a big pleasure to receive Dr. Alicia Durán today here for this talk. Let me say some words about Alicia for those that eventually don't know her. Alicia obtained a degree in physics from the National University of Córdoba in Argentina and a PhD in physical science from the Universidad Autónoma de Madrid, developing her professional career at the Institute of Ceramics and Glass of the Spanish Research Council, CSIC. She's responsible for the Glass Group, with more than 250 publications, with more than 7,000 citations. The famous age index is 47, which I must say that is the highest index in Spain in material science. Alicia has directed 14 PhD theses, published 12 books, 14 book chapters, and she is the co-editor of the International Journal of Applied Glass Science, which is an important journal for the glass field. She was president of the International Commission on Glass, ICG, in the period of 2018 to 2021. She received the Phoenix Award from the international glass industry, being named Glass Person of the Year in 2019. And she was recently honored with the Otto Schott Award this year. She is the chair of the United Nations International Year of Glass that we are celebrating now. And we are today starting the celebrations of the International Year of Glass with the talk from Alicia Durán. I'm sure that we will enjoy very much. Alicia, gracias, thank you. The word is yours.
Okay, thank you a lot for the presentation, Sidney, and I really appreciate this invitation, really to share with you why we are celebrating the International Year of Glass, and which are our goals, and which is our first objective. I will pass really. It's the presentation is not open in presentation model because it has some problems really to pass the slides. Well, to go to the beginning about glass, we have to go to Pliny the Elder, that recounted that everything began on a beach near Tyre and Sidon in a nature merchant camp. The nature is the natural mineral of sodium carbonate. There in that beach, the sand, the fire, and the natron reacted, and the next morning they were transparent and hard glass beads appear in the beach. The glass was born. So from there, really, it passed from Egypt and Babylonia. In Egypt, first, more than 2,000 before Christ, in Egypt, it was invented the method of the sand nucleus, really, to make hollow perfumes containers, for example, knowing that the glass is totally close to the path of gases, and so it perfectly contain and the essence and the perfumes, for example. From there it passed to Babylonia. In this case, as glazings on enamels on the walls, and from there they arrive to Rome, in which the industry, really, the glass industry, appeared. In the 2nd century before Christ, it was the first technological revolution in glass, with the inventing of the glass blowing. The glass blowing permitted really the great development of the glass industry in Rome. And from there, it was expanded to the whole Roman Empire. So the Rome is really the responsible of the so wide expansion of glass factories in all the Roman Empire. In Rome also, farther than the usual materials and products that they were available to all the population, they also reach the heights of glass art, like this multicolor bowl, or the Portland vase, or this head of Augusta that they are at the British Museum in London. And of course, this wonderful Licurgo vase that is, up to our knowledge, the first nanomaterial really in the glass science. Why? Because you can see that it has different colors depending on if they are reflecting light or transmitting light. Why it is? Well, because this glass has very fine, small particles of gold and some of silver, really, and they have this effect of the plasmons really provided by this gold colors. Well, moving forward, the techniques advanced, and they went to blown glass. Really, remember the glass blowing. It was invented in the 2nd century before Christ, but it was developed really from the 15th to 17th centuries, really to produce bottles for wine, usually, and also from hollow glass and glass containers, it moved also to flat glass. And in the flat glass, really, it was another revolution. This is an architecture revolution, the revolution of Gothic that permitted really to transform the church and the sacral buildings, really substituting the very small windows of the Romanic previous to Gothic by very high and big windows that permitted really to the light to enter in the church. And since these windows were covered by color glasses forming these stained windows, they were able really to tell stories to the people, mainly the stories of the Bible and the life of Christ. From there, for example, this picture from the French encyclopedia describes the invention of the casted flat glass in France, in the royal factory of glasses. That it was the first multinational of glass. This is Saint-Gobain, that it was born in 1667. Okay, and from this evolution from the Gothic, they pass really to the 19th century to the discussion, new discussion in architecture, really relating the architecture with glass and light. And from there, to in the beginning of 20th century, they were the glass houses that they were, for example, these of Van der Rohe in California, but also many in Brazil, really, for example, the glass houses in Sao Paulo. And from there, that they were really very nice and very illuminated, but glass, single glass, is not an isolant, really. And so they were like a heat island in there. But they really, evolution developed really to this carbon neutral glass skyscraper of transparent and sustainable cities that are in our cities in this moment with these smart and isolant glazings. Of course, from the very beginning, the glass was very important in optics. And this is the Galileo telescope in 1627, really, and that permitted to look, to see the planets, but also to follow the movement of the stars. And Newton could use these measurements of the movement of the stars, the measurement made by Kepler and Tycho Brahe, and from there he was able really to enunciate and present the gravity theory. And from that telescope to the wonderful James Webb Astronomic Telescope that was put in orbit in last December. This telescope will permit us to go behind 13,500 million years, really, to assist, to attend, to study the very, very beginning of after the Big Bang. Well, and of course, glass has a protagonist role in clean energies. First, the concentrated solar energy that they are glass mirrors that make coincide the reflections from the sun in a tower, producing vapor, and from there producing electricity. Or these photovoltaics in which the solar energy is directly transformed in electric energy. And of course, the aeolic energy. Where is the glass here? It's in this in the turbine blades. These turbine blades that they are bigger and bigger because the idea is to increase the energy produced for each windmill. These blades are made by, they are composites of polymeric matrix with glass fibers, glass reinforcing fibers. And the biggest has in this moment more than 80% in weight of glass fibers. The other so important application really are glasses for health and well-being. And there are many applications. Really, from the last 15 years, glass is the preferred material for in biomedicine. In particular, for example, these scaffolds that they are used for fulfilling bones, for example, in cases of accidents, or break-ins, or also for old people really with these problems. Which is really the idea is that the human body recognize this glass as own really, and so it's this is not rejected like it occurs with other materials. In the last years, not more than 5 years, it appears this type of tissues that they are like, like the sugar for children, really. They are the tissues that they are made by very, very fine borate glasses, and that are able really to heal the persistent wounds. For example, these wounds that appear in diabetics people. In the field of odontology, there are hundreds of applications. In practically all the materials used are glasses or glass ceramics in this area. And of course, we have not to forget these wonderful and miracle small bottles that came to save humanity with the COVID vaccine. These are not usual glass containers, but they have a very, very high chemical resistance and a very, very high thermal resistance. Remember that some vaccines need to be stored at minus 100 degrees centigrade. Well, and we arrive to the last, but I think this is the most important really application and the most important for the development of humanity. That is the optical fiber. From this first optical fiber, the monomode optical fiber that was invented and developed in one lab in US by 1964, around this, it was from the very beginning, only some years after this, it was began the study of how to substitute the copper coaxial cables, really, that they were the way to transmit information, really, in the telephone networks, to use optical fibers, which is here the idea that in case of the cable and the copper cables, who is transporting the information? They are the electrons, and the electrons move at a frequency of 10 to 7. These are 10 million bits per second, for example, translating to information. In this case, we are changing the electrons by photons, really the quantums of light, and so we are increasing in this first step from 10 to 7 to 10 to 15. So we are increasing 8 orders of magnitude the amount and the speed of transferring and transporting information. This was the idea behind the internet. That internet was began to be developed and studied in California, really in the 70s. From that moment, really to our times, these monomode fibers has really changed a lot. And here you have some models of structure or photonic optical fibers, like they are called, in which they are really hundreds of small channels, really, that multiply in a single fiber the transport, the amount and the velocity of transportation of information. This is the 5G, really. It's so the optical fiber are the hidden, invisible base of the revolution of telecommunication. Internet transformed the communications, really triggering the globalization processes. And we all know, really, that globalization is had a really huge impact in the economy of the planet in the national and international economy, but it's also a social process. And nobody can think how it was our lives in the pandemic without internet. Because remember that the internet permitted us to work at home. The children follow with the schools, the teachers teaching, and we all connected really with our friends, our family, really, and we can say really that the optical fiber helped us to be less alone. Okay, these were the arguments, the main arguments we used to justify that we are entering in the age of glass. It was the conceptualization of this concept it led to the idea of presenting and getting a United Nations International Year of Glass. David Pye and Manoj Chaudhary presenting this proposal really to search, to investigate if it was possible in the ICG Congress in Yokohama in 2018. I assume the presidency of the ICG in that Congress, and I accepted the challenge. So I contacted with the Spanish ambassador in United Nations that it was the serendipity, that is, it was an old friend of mine that, I haven't been connected for 10 years, really, because he's a diplomatic and it was in Africa and in others, but he immediately accepted this to lead the eye job, and so he indicated us how to present this and to look for really the role of glass in the different sustainable development goals of Agenda 2030. And when we were there, we discovered that glass is protagonist in 11 of these 17 sustainable development goals. All this work was confirmed by Nature in last November, where they identified glass with sustainability. They say that glass is the hidden gem in a carbon neutral future. And so they confirm that we can construct to build a more sustainable planet with glass. And they are respecting to sustainability. I have given you a list of applications in which sustainability is very important, but they are two big applications in which sustainability is really the aim and the goal. The first one is glass containers. Glass containers really is the glass recycling existed from the first times of glass fabrication, from Tyre and Sidon and to Rome. Really, they are, for example, we have in Merida that it was a very, very important Roman city in Spain. They were four factories, glass factories, and they are an important documentation proving that the glass that it was broken or used, it was recycled and enter again in the furnace. So from the very beginning, glass was fostering the sustainability and leading to the circular economy, although this concept of circular economy was not, did not exist in that time. Well, really from the discovery of the glass blown in the 2nd century before Christ, the glass containers developed. They were in Venice. It was the first time that the wine was stored in a bottle. Then they passed to Germany and to Great Britain, and where they are really bottles very similar to the nowadays bottles. In 1650, it was a very special year because the cork stopper was invented. And so the glass bottles from that times are used to contain, transport, and reuse. This is the same function that the glass bottles has in nowadays. The other is 1 century after, when Napoleon was organizing the campaign to Egypt, he opened a contest really to find some methods for conserving the food for the army. And so it appears Uppers, that was a cooker that reinvented as industrial or that patent the conservation of food in airtight containers. This is again the same method that we still use for the conservation of food, and that is very, very efficient and safe. Well, and here really the glass containers participate really in at least 3 of these sustainability goals of the agenda. In this, for example, in treatable cities and communities, because glass container can lessen the solid urban waste, and if we apply the 3R rule, this is reduce, reuse, recycling, this philosophy is vital, is crucial for sustainable lifetime and waste management, leading to a perfect circular economy expressed as from cradle to cradle. This is the glass is never waste. And on the other side, in the case of responsible consumption and production, this sustainable consumption means to do more with better, and to do more and better with less. And so glass is innately environmentally friendly because they are made with the raw materials more abundant in nature, and since the recycling rates are very high, and industry actively seeks for more energy efficient melting technologies really to reduce the carbon footprint. So this concept of circular economy can be understood as the main tool to commit really the challenge of the global change, because glass, it's a material in which we can combine the goal of taking or getting economic and ecological value creation. We can create and fabricate without damaging the planet. Well, and we have the objective, the goal 14, it is life below water. Well, really, the world's oceans and rivers, the temperature, chemistry, currents, really, so they are driving the global systems that make the Earth habitable. So we have to take care from there, and we know really that plastic is polluting them, creating islands of plastic that inhibit the sea life under the sea. So glass is the glass packaging, the glass containers are infinitive recyclable and safe and clean alternative based in natural and abundant materials. And in case that glass is broken and they appear polished by the nature, by the sun, really, and they convert, really, they become a mineral again. Here you have, this is a very nice beach in California that is called the Crystal Beach, because it's full. Nobody knows why, full of small pieces, really, of color glasses. And what we are doing in Europe, for example, for recycling, the container glass collection in Europe is very well managed and increasing the rates. The last numbers that they are 219. It's in the European Union of 28. Well, now we are 27 because Great Britain went ago. And in this moment, 78% of containers were recycled. And so from the European Association of Glass Container, FEBE, it was designed really a project that is called Close the Glass Loop, really. It's a European value chain vision for a closed loop circular economy, in which it is all the people in this value chain. This is from the people that from the glass industry to the they produce the bottles, then they go to refill, then they go to be consumed, and then they are recycled and enter again in the cycle. The idea really is to increase and to enhance the recycling taxes up to 90% in 2030, and to arrive to a better quality of the recycled glass. These objectives are much in advance than the European objectives in recycling of other materials. And which is the idea? The idea is really to pass this linear economy, in which the idea is to take, to make, and to dispose, really to enter in a circular economy in which we make, we use, we recycle, and enter again in the same circle. The other big application of glass in which the sustainability is really very important is the flat glass. This is the glass for architecture. Really, I have to say that between there are many. I have shown you really a lot of applications. Really, but I have also to say that measured in tons of glass produced, the addition of glass containers plus flat glass for architecture and also for cars, of course, they can explain about more than 90% of the tons of glass produced. So really, they are very important applications to convert and to become sustainable applications. Well, and I go really to the 19th century, in which it began the discussion in the world of architects about glass, light, and architecture. Really, and at the beginning, the glass architecture in the 19th century really it's correlated with speed and temporary structure, like exhibition halls, for example, this in 1914 in Vermont, and this other, this a casino in Montreal built for the Expo of Notre Dame 1 century after, really. Or, of course, this was very often used. The rail stations, for example, in which the natural light illuminated really the station. From this station in Paris from the 19th century to this Atocha in our days. These type of applications are more and more extended, in particular to airports, in which all the airports contains more and more glass, really, with the idea of course of taking profit the natural light. And from there they passed just in 20th century really to the practically philosophical discussion on glass and architecture. For example, talking about the American skyscrapers, really to industrial plants. For example, in the skyscrapers that they were rejected by Russian, for example, because they took like a model or an icon of the capitalism. But for example, in Germany, they call the skyscraper as the new cathedrals already. And talking about cathedrals, really here in the right, you can see a wine cathedral. These are many really in Catalonia, in Spain, that it was a very rich region at the beginning of 20th century, and that in the way of modernism, they constructed these wineries that like really real cathedrals, and they are called the wine cathedrals. Really, they are very nice. Now, in these years, they are really arriving to the centuries, to the 100 anniversaries, and they have. I have been last year in 3 of these. They are really wonderful. And this was the 20th century, but our century, the 21st century, the debate includes a new challenge. That is not only glass, light, and architecture, but we have to add another word: sustainability. Really. And why we have to do it, really? Because when we make the distribution of CO2 emissions, we can say here in the left that we have 30% for industry, 22% for transportation, and we have practically 40% of the world CO2 emission are linked to construction, really to buildings operation, and for example, also we have to include the heating and cooling for this. So we need, if we have to drastically reduce the CO2 emissions and all the greenhouse gases, we have to drastically reduce these CO2 emissions from buildings. Okay, and we have to look how does the glass contributes to the emission during manufacturing, because we have to begin from the very beginning, of course, because we know really that glass melting is a very energy-intensive process. And so we have to think about how we can reduce these emissions. Well, the glass melting incorporates, emits 0.6 kilograms of CO2 per kilo of glass produced. It's a little smaller than the energy footprint with cement, steel, or plastic, but is still very, very high. Well, what the industry is doing? Well, there are many things the glass industry is doing really to reduce this energy intensity and to reduce the footprint of the glass production. The first is this project called Furnace for Future, really, and in which we can add the question, evolution or revolution. Yes, if we change, we modify the current furnaces for melting glasses, or we totally change the structure and the method of melting. The first the question really is to change the energy vector. We have, of course, to eliminate the fossil fuels like gas or fuel directly, and so to substitute these energy vectors by renewable energy or inclusive the use of pure hydrogen in the furnace. The other tool is the electrification, really that to change the gas for electricity, and this change totally the structure and the design of the furnaces. This is, for example, electric furnaces are really very well known from 1890. For 1890, they were the first electric glass furnaces. But they have, and in this case, really the glass is heated by this type of electrodes that they are in the base of the furnace. It can be do it. For example, this a cold top all-electric melter. Really, it's working with a very low, very high efficiency, with a very low energy consumption. But this is the problem, really, that the maximum size of these furnaces is around 80 or 100 tons per day. And 80 to 100 tons per day. And remember that in this moment, a float furnace for producing flat glass is from 800 to 1,000 tons per day. So it's one order of magnitude bigger than these glass electric melters. Here, for example, you have all these, they are examples that they are working really. And here in the right, you can see an hybrid oxyhydrogen fire. This is with pure hydrogen melter. In this case is 350. This is this is better. This is the usual size of a glass container furnace, for example, and also with a very high efficiency, with 80%. This is very important, of renewable electric and zero CO2 emissions. This is very nice. So the other thing is to increase more and more the color. This is the recycled glass, because you can save 3% of energy for each 10% of raw material that you substitute in the batch. Well, and if we enter in the problem of glass and climate change, we can identify really that glass is a small part of the problem, and it can be a large part of the solution for the climate change. For example, in the European Union strategy to 2050, Europe is proposing carbon neutrality in 2050. This is to eliminate directly the CO2 emissions. So what type of tools we have in glass? We have the products that they are insulating fiberglass, advanced glazings, continuous fiberglass, and special glass applications that we can really, with this, we have new and innovative products as passive insulation, low emission and solar control glazing, solar cells, solar thermal energy, wind energy, and of course more emission lighting with the LEDs, for example. From there, we can really confirm and prove positive energy balances, and the goal of neutrality of CO2 emissions is possible to get in 2050 with, and of course, a much lower energy consumption. And we began, for example, in construction with insulated materials. Which insulated material? This is the glass wool, really. The glass wool, you know, it's glass fibers with air, really, and the material has much more air than fibers. And so in here, in the left, you can you have the emissivity of the different materials, and here you have air. This is in watts per meters and Kelvin, and here you have this air that is 003, and this is glass that is 1, but this is 0.6, but this is glass when you have the wool. This is you can see here you have the price and the emissivity. Here it's in milliwatts instead of watts, and here you have in yellow they are the different products of glass wool. And here you can see air is 30 milliwatts per meter and Kelvin, and the glass wool, depending on the product, they go from 30 to 40. This is very, very similar to air. And these materials, you can add really very good mechanical properties, compressive strength, fire resistant, water uptake, and acoustic insulation. And there is other very important question here, that they are very cheap. So they are cheap, efficient, and effective, really the perfect material. And here you have these materials. They are used extensively, really, to isolate, for insulation of glasses, for example, for the roof. Of here, for example, they call glass veils. Then they are started a light in which you can cover, for example, the outside for new insulation of just constructed buildings. And these insulated materials are changing the paradigm of architecture, really, to lighter construction, really, in which you can reduce the concrete to a few structural elements, of course, and to use different materials for facades, like as plasterboards or glass made for waterproof and increased mechanic. And so it's possible, really, to calculate a potential reduction of near 60% of global warming potential, really, with this. Because here, for example, is clear. With 1.5 or 2 centimeters of insulated wool, this is the same that 30 centimeters of solid brick or 1 meter of concrete. So you can have a much more efficient insulation with less thickness and much less weight. And of course, they are much cheaper, and they have an additional sound insulation that is more and more important in our cities. The other protagonist of this, they are the advanced glazing. And For example, you have here in the list the low emissive glazings. They are double glazing, in which there is, if this is here, this is the heater only, and in the back of in spatial glazings. What are they doing, really? They compare the emissions of CO2 during the manufacturing, this is the production and manufacturing of this, with the energy saving produced by the installation of this glazing. And so you have, for example, for manufacturing 1 square meter of low emission double glazing, you emit 25 kilograms of CO2. But for the saving, you save when you substitute 1 square meter of simple glazings for low E glazings, you are saving 91 kilograms of CO2 per year. So you are in only less than 4 months, you amortize, this is the amortization of the emission. In only 4 months, you really save more CO2 that the CO2 use for the production. And it's less than 1 year, really, for double glazings in case. And there is these smart glazings have a very high potential of saving of 96 megatons, or millions of tons of CO2 per year in Europe in 2020, really. And these are, for example, other reports about the possible energy saving in energy and also in CO2. And for example, in the case of the summer and the hot cities, as yours and ours, really they have here the control glazings, and it's clear really that we can save a lot of energy and of CO2, substituting, for example, in this scenario, substituting the glazings by solar control, well, low emission and solar control glazings in all the new buildings, and substituting this for the non-solar in the old buildings. With this has savings between 16 and 86 million tons of CO2. So these are really the tools. And here, for example, is an example of energy saving in a house in Sevilla by using low E plus solar control glazings. Here in the left, you can see the energy demand well, here we have the different seasons. In January we are in the winter, July, August is the summer, and December again the winter. And so really here this is the comfortable indoor temperature range between 20 and 26 really, and here you have the energy demand in both in winter and in summer. And here you have the energy demand in the same building, really only changing the glazings by smart low-E solar control glazings, in which you are reducing the energy demand and the CO2 emissions in more than 90%. We are reducing to less than 10%. So really, this is the possibility of using thermal insulation and solar control of construct houses totally made of glass that they are neutral in carbon. They are, well, this is a building constructed by Saint-Gobain near the Mont Blanc, and this is another glass house in Scotland. Really, well, they are both, as you can see, in the snow, really, and they prove to be really energy energy efficient. Well, you have also other type of advanced glazing. You have reflective and anti-reflective, and in the case of active coating, you have self-cleaning, the change of transparency and turbidity, electrochromate, nightly, photovoltaic. So really glass, with all these applications that they are increasing, and they are new application each day, convert glass really in the protagonist. Here you have the reflective and anti-reflective glasses. You have the self-cleaning coatings that in which by photocatalytic degradation of organic stains that they are activated by sunlight, you can maintain clean the glazings, and only with rainwater. And here you have, for example, the electrochromic coatings, in which you can only change a little the potential, really, to change the color and the intensity of light as you wish. And of course you have these other active coatings of photovoltaic that they are more and more used in the roof of the individual, really the familiar houses. Now really they are carbon reducing strategies, really, that in which they are being assumed really by architects and engineers, really, that is to minimize the waste, to build efficiently, to build clever, to build less, to build nothing. For example, only changing and modifying the just constructed buildings. The idea is to recycle single and double glazings and laminated glasses is a big challenge in this moment. We cannot, we have said at the beginning that glass is never a waste. But in the case of flat glass, we need really a recycling system of these glasses to arrive to this objective of repurpose, reduce, reuse, recycle. Of course, we have to, if we are really going away from forest, we have to introduce forest, to introduce green and trees in our cities, putting the nature in our cities. So we have, and these are my last slides. I wish to show you really what we are doing really in the International Year of Glass. We have published this book, Welcome to the Glass Age, that in which we really go through these objectives of sustainable development, really going through all the applications, and we have published also in Spanish, and we have also two exhibitions. They are itinerant exhibitions that with arrive 2022 panels. With in one this glass present and circular present and future. This going around Spain and now entering the glass age, or that is we are arriving to the last of the layout. Okay, and here there is really the opening ceremony in Geneva. It was held from 9th to 11th of February, and really in this wonderful room of human rights. And here they were the very lucky people, really, because by the restriction of COVID, we were permitted only to be there, well, up to 170, but we were 140 something, really. It was an amazing experience, a very nice conference with the top speakers, 30 speakers. Really only 8 were online, all the other were in person there, and it was really an amazing experience, and it was the most biggest attendance in all the history of a glass event. On Friday, 11th February, there were more than 4,200 attendance by the TV, really, of United Nations. And you can still enter and look and visit all the event on 10th and 11th of in the TV of United Nations, only put in IJOC and it appears. So we are making also a lot in these moments. They are under development, hundreds, thousands of activities all around the globe. Really, we have more than 2,200 endorsers from 90 countries, and there are many people working and imagine different activities in art, in education, in publications, in every really. And from there, really, we are very proud of this year, and we can say to all of you, welcome to transparency, welcome to sustainability, welcome to the age of glass. Thank you very much.
Thank you, Alicia. Muchas gracias. Wonderful talk. It's really beautiful. And I think you really showed us the importance of the glass in our nowadays. Are you available for a few questions from?
Yes. I can. Because it has taken, well, when I begin talking about glass, you have to
Yeah.
help me, really, if not.
Yeah.
But I am available and I can answer some questions.
Before asking the questions, I just have a comment. I wrote that in the chat. That people can imagine, try to imagine in the last 2 years, without the telecom systems, the optical fibers. We survived due to the systems, to the telecom system. We are in contact now with your talk because of the optical fiber telecom system. So it's without doubt that it's a very important material. And I think it's the only material attending the circular economy principles, because no other material we can have a real circular based processes. But anyway, I think we all agree that the International Year of Glass, the proposition of that, thanks to you, is very much deserved. Thank you very much.
Thanks to you, Sidney.
So, do you have questions here in the meet room?
Okay.
Any questions?
Yes, I have a question.
Okay.
Marcelo, go.
I would like to have a here later.
You like it? Really? It's a very nice.
Yeah. You said that, sorry, Marcelo, but Alicia, you said that this book is available for translations in other languages.
Yes, we can really. We are offering really the layout.
We can take this challenge to translate to Portuguese if you agree with that.
You can. We will facilitate you really the layout in the software. This is practically a universal software. Really. So you have there the layout, and you have to.
I will discuss with Marcelo, and we will do that.
Okay. If you ask, I will send the layout. I can ask for the layout in English or in Spanish. Maybe I think it will be more useful for you in Spanish because the length of the text in Portuguese is more similar to Spanish than to English. Right?
Yeah.
But you have only to ask really, and I will provide. It will be also translated in Hungarian, really, and maybe in Japanese and Chinese.
Nice. Very nice. Go on, Marcelo. Sorry.
Now, I would like to know, Alicia, after all this, of course, the beginning of this year and all the things that has happened about the International Year of Glass, what you're feeling about how people are seeing this movement? Have you, in your place now, where you are now as a protagonist of this, how can you see that people are thinking different, or how this glass image, this glass universe coming to the people now?
Really, we are you're surprised for the impact of the Year of Glass, because there are thousands really of activities, and there are many activities focused in education. That is a major goal, really, because when the children, students take the idea, they are the best people to disseminate these ideas. But for example, here in Spain, we have organized the iJob in different regional committees by geographical of language, because it's impossible really to coordinate 19 countries really centrally. No, you have I think Brazil is the regional committee 1 really, and you are alone. Really, but for example, in Spain, we are the regional committee 8. That we are Spain, Portugal, and Andorra. Well, we have this, and we are receiving the proposals of activities, and there are so many activities, really, and all the people is very enthusiastic. For example, we have this is here in Spain. We have the recycling of glass. The management of the recycling is managed by an integrated system that is called Ecovidrio. Ecovidrio is the manager, really, and the responsible of the glass recycling. And so they are making so many activities. For example, this is a very nice idea that is growing and growing, that they are the towns twinned by glass. So what we have done, we have identified in Spain different towns or small towns or cities, really, with something related to glass. Maybe the history, maybe an old factory, maybe a great factory, maybe now the cities with glass factories and so on. And we offer them to be twinned in glass, and we deliver one key of the town made in the Royal Factory of glasses with recycling glass. Well, this they are so enthusiastic, really. We have now, in this moment, in only 2 months, we have 40 towns that they are twinned in glass, and they commit to increase their recycling tax and to promote recycling in these towns. And we will arrive surely to 55 at least at the end. And now this idea is being replicated in United Kingdom, in which there are now 5 towns, and also in Italy. Well, with the further goal of constructing a network of towns linked or twinned by glass. This is one, really, but there are many. For example, there is a contest promoted by the Indian Association of Glass Producers. They are organizing this. This has been the third year in which they make a call for students, the small ones, and the college also, centering glass. One was they were drawings, for example, or picture that with the topic glass protects us. This year they were small text on glass, and they have thousands of answers, really. And now they are replicated in Iran, in Pakistan, and in China, really. And with a great answer, really, with a great impact in. And all this we tried really to share in the website of iJoke. There is you can look at all the activities and events that they are they are proposed and planned, and you can search by date, by city, by country, and by type of activities. There is a huge activity in the area of glass art for individual artists, for museums. One biennale in Costa Rica. Well, there are hundreds really of activities and events in art, for example, and also many congresses and publications, and there will be special issues of all the big the IJAX, the Journal of Solgel Science and Technology, the Journal of Non-Crystalline Solids, Heritage, that is the most important journal in archaeological. So there are many activities that they are coinciding and they are triggering really new activities.
Thank you. It's great, really great. Just 3 weeks ago, I had the opportunity to participate in a conference in Canada, in Quebec, organized by UNIS. And they mixed artists, science, industry, and it was really, really amazing. It was a very nice experience. The artists stay with us during the whole conference, so we can change our different views, and it was really, really nice. It was something that must be done other times, in other places.
And you know that we made a very big fundraising campaign for the opening ceremony in Geneva, and we got much more money than the necessary for Geneva. And so, well, we arrived practically to €500,000, and we save really half of this. And so we decided to invest in projects, really in activities. We have planned 2 calls. The first call was in April, really to distribute 100,000, euros, and we really expected to receive, 30, 40 projects. But we received 90 projects and requesting for 900,000 really. So we had to really to reduce, of course, and now in July there will be the second call, and with better explain really rules in which we put the last 100,000 euros, and really we invite all the people really to participate, to really to present. It's very easy really to present, to think about one activity, and the only request is that it's a type of seed financial, so this is a complementary finance of a project. And the idea of there is no much money, because if not we can only finance a few projects, but I think that taking 2 or 3 or 5,000 euros may help really to complement and produce new activities. And so you can participate, you can, the idea is, well, it will be open, we will really inform, and you will be informed about this, and it will be open in July, and well, we will decide at the beginning of September, because we have the summer in the middle, really, and well, to receive money for activities that have need to begin in 2022, but can finish, if it is an exhibition, for example, or a course or something, it can go up to 2023.
Okay, nice to see. Thank you, Alicia.
We have a question from the chat made by Silvia, the aunt of Gustavo, and she's saying it's about this. Okay.
Wow.
So she's saying that today plastic is used as containers due to practically such as weight and fragility, although only 40% is recyclable. What are the prospects of reintroducing the use of glass back into the market? How to solve many of the problems concerning weight and transport?
The question really, it's a good question, because recycling is quite easy to organize in Europe, in which really the distance, the countries are relatively small, really, and for example, we have in Spain, there are 13 factories of glass containers distributed in all the country. And so all the recycling is organized around these factories, and so the transport really is really minimized, because this is important. This is more difficult in Brazil or in Argentina, for example, in which the glass container plants are very really very far one from others, and so is it's not cost effective. For example, taking really the cullet, this is the recycled glass in Rio, for example, and have to take to transport it to Sao Paulo or to Recife, in which they are others. So this is a problem, but because transport, the cullet and the raw materials are very cheap, and so if you have to transport it, the cost increases. But we have to think about, really, we have to arrive to a system in which we can really recycle, because the recycling glass containers means really to reduce the use of raw materials, to reduce the management of waste, and of course, and more important for industry, to reduce the energy cost. You know that you are saving up to 3% of energy for each 10% of raw material that you substitute. And for example, in green glass, this is the glass for wines, for example, that they are usually green. They can use up to 90% of recycled glass, really. And so it's very important, really. So we have, I remember many years ago, around 10 or 15 years, we were working really with the glass center of the Institute of Technological Industry in Buenos Aires, really, and trying to design a type of recycling system in which, for example, to use not only the national factories, but all the regional factories. And for example, in the case of Uruguay, they have a recycling system, but they have no glass factories. So they could send this recycled glass to Buenos Aires, to Verazategui, where there is a big one, or the same in the north, or the same in the south of Brazil, with the northeast of Argentina. And it's not easy, but we have the tool, because this is the Mercosur, in which, it's important, really, and it will be surely necessary to negotiate, to make some time, because at least is a waste, but we have to use like a raw material. But it's clear that we cannot abandon really the idea of recycling, because really we are converting money in waste. It has no sense, really. And respecting to the fragility, it's true that it's more fragile, but they are in this moment, there are many different in 2022. Really, we can combine a much lighter bottles or jars, really, with 100 better mechanical properties, and so it's true that we cannot use glass for a 2-liter bottle, for example, of Coca-Cola, because if it breaks, it's like a bomb, really. But they are the glass containers has really increased a lot the mechanical properties, and they are safer. They are the only containers that they are recognized as food safe, really, and there is no other really like this.
Okay, thank you. I was when you were showing the CO2 produced.
Yeah.
I was surprised by that, because we always thought that the glass industry was a very high energy demanding industry, and you showed that it's lower than the plastic and the
Yeah. Much lower than plastic.
Yeah. That's
Because in the plastic, this is really there is the life cycle analysis, really, in which you analyze really all the chains. But you have to in this analysis, you need to start from the very beginning. And so from the people from, I have really discussed a lot with people from polymer containers, that they say no, because the melting of glasses is much energy intensive, and say no, because you have to begin from the beginning, not from the material that you receive and only you form, but from the very beginning. This is fuel, this is petroleum, really, and this is quite impressive, intensive. So this is, you have really to study the whole cycle, really, and in this case, the glass is the lowest level.
Okay, thank you. Do we have more questions? Not in the YouTube, not here in the meeting. Okay, so we are Danilo saying that presentation was wonderful.
Thank you, Danilo.
He will meet in Berlin.
Okay. 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 Who is coming to Berlin?
Marcelo.
Marcelo. And you are going?
Danilo. No, I'm not going.
Danilo and Marcelo. Okay. See you there.
Sylvia also will be there.
Sylvia also is good.
Yeah,
Okay.
there are many
And
people.
Anna will be there also. Well, they will, I think, Edgar, I don't know. There will be many Brazilian colleagues.
Yeah. There are also 3 students of mine that are in France now that you also, they are also be in Berlin. So, 2 minutes.
Okay. See you in Berlin. So, okay. Bye-bye. And thank you.
With this we finish. I think everybody agrees with me that the presentation was wonderful. We enjoyed it very much. Thank you very much.
Bye-bye.
And see you next time. Tchau.
Ciao.
Tchau, pessoal. Tchau, tchau.